How y'all doing today? Good. Coming good. Okay. Again, I don't want to insult your intelligence going too slow over to review stuff, but I also don't want to leave anybody behind. So if you're a super genius, uh, great job being a super genius, but we're not all that. So bear with us until we get to killer new stuff. All right? I'm actually thinking about moving something up to tomorrow to start challenging you a little bit, so you get a challenge. Please. Yeah? Okay. So are you feeling a little Delta Epsilon proof tomorrow? Yeah. You're going to say no after you see it, but wait till you see it. No, you're kidding. I love it. Okay. A real quick limit review, and also focusing on what I'm picky about and what I need to see in my work so you're graded fairly, which might be different than what somebody other, maybe Ms. Kenna might be picky about. First of all, we talked about DNEs yesterday. I remind you that if you offer DNE, you must justify with two pieces of evidence. The one-sided limit's not equal, and what their limits are reported. Okay, so for example, say you had ye old, the limit as x goes to 2 of x minus 2 over 2 minus x. As an example, classic Calc 1 problem. Upon direct substitution, you get ye old result of 0 over 0. That's a problem. Does that mean DNE? No. No. Okay. If 0 over 0 meant DNE, then every derivative would not exist. That's ridiculous. Okay. 0 over 0 just means do more. Right? Every derivative as a limit comes out 0 over 0, so you can't just fail it. Can you do any algebra to do a little canceling, for example? Yeah, absolute value, not so much. So, we're left with either graph or table. Do you know the graph of that by heart? No. Me either. Either. Let's call the whole thing on. So here we go. Then let's go by a table, shall we? I'm going to call this, let this be f of x, so I don't have to rewrite it. All right, so if you do a table, then you're approaching 2, and therefore putting it in the middle, you're approaching it from both sides. So your table should be structured like that. Tables aren't kid stuff. I require you to be able to do a table to teach you delta epsilon proof. So you've got to be able to do a table well, including with the calculator if you need to. So if we're approaching 2, we might approach it from the lower side by maybe, 1, and then, let's say 1.9, I think will do it. At 1 in the function, what do I get on the top? What do I get in the bottom? 1, and so it is 1. At 1.9, what do I get in the top? 0.1, what do I get in the bottom? And so that is, it appears then, the limit from the left is 1. I think you'll agree. The trend of 1, 1, 1, 1, 1, 1, 1, what's next? 1 is obvious. How about approaching from above? For example, 3, then 2.1. If I put in 3, what do I get in the top? 1. What do I get in the bottom? And so the quotient is -1. In fact, you're going to get -1s again. If the left-hand and right-hand limits are not agreeing, then the limit does not exist. In terms of expressing evidence, you would say something like this. DNE, because the limit as x approaches 2 from below is equal to what? 1, and that's not equal to the limit as x approaches 2 from above, which is -1. Okay? Now, in terms of how I would grade this, if I were to grade it, it would be 1 point for DNE, 1 point for limits, one-sided limits not equal, and then 1 point for the actual limits themselves in evidence. 1 point for the limits. You must give evidence. You cannot just say, the one-set limits aren't equal. You must say what the one-set limits are. And they're right in my math world. You follow? Okay. Direct substitution. You guys already know that when you go to evaluate a limit analytically, the easiest possible thing is rather than saying, well, the limit is getting closer from the left and getting closer from the right, isn't it easier just to go right to the point? Yeah? And that's called direct substitution. If I just put direct substitution, direct 2 in, what do I get? 7. Now I can do that because the limit from the left, the limit from the right, and the point themselves, they're all one and the same. In other words, the function's continuous, and so direct substitution works peachy. Okay? An algebra case where you get kind of a no-go. Say you'll limit as x goes to 0 of root, let's not say that because that's a little bit funky. Let's say x goes to 4 of root x minus root 4 over x minus 4. We haven't done derivatives yet, but what does that remind you of, or what derivative is it? Derivative of square root of x at 4. And what definition of the derivative is that? The original definition, the alternate definition, or the symmetric definition? It's the alternate definition. We'll talk about that later. Okay, and that vocabulary might be a little different, but that's pretty common. All right, wouldn't you agree we're going to do this in a non-derivative-y kind of way, right? In a limit way. Upon direct substitution, you get what over what? 0 over 0. Now that's a problem. We need to go further. What algebra can be done? Multiply top and bottom by x root x plus 4 root 4. I guess we could call that 2, could we not? And root x minus root 4. Should we just call this 2? Forget it. Okay. Do you mind if we call that? Well, that's good. Whatever. Okay. So at any rate, the limit as x goes to 4. What does the numerator become? X minus 4. The denominator, keep it factored out. X minus 4 root x minus root 4. Did I make a mistake?
Should be plus.
Okay.
Plus. Oh, plus in both cases. You're correct. Yes, you are correct. It should be plus. Thank you. Sorry, my bad. And it actually should be, yeah, no, that's good. At any rate, the x minus 4 divides away, therefore dividing out the 0 over 0 problem, and your final answer is 1/4, which would represent the slope. Okay. All right. Infinite case 1, infinite case 2. These sometimes result in errors on the multiple choice. So I'm talking about, in both these cases, I'm talking about either x goes to a constant, y goes to infinity, or y goes to a constant, x goes to infinity, or vice versa. So they both mean two totally different things. Let's say x goes to infinity case. Okay? For example, the limit as x goes to infinity of 2 minus x cubed plus x over 5x cubed plus 7. If I say what's the limit as x goes to infinity, I'm really asking what's the end behavior, all right? And what can I strictly focus on?
The largest.
The largest. The largest and how they relate and who wins. These kind of knock each other out, and so this would approach negative 1/5. It is important that you understand graphically what's going on here. What's the graphical interpretation of just what just happened? The graph has a horizontal asymptote. Graph has a horizontal asymptote at x equal negative 1/5 or y equal negative 1/5? Right? Infinite case 2 is when you get an infinite result, rather. The limit as x goes to 0 of 1 over x, and let's compare that to the limit as x goes to 0 of 1 over x squared. The first one, what do you get? It is dne because, is it because it's 1 over 0? No, that's not why it's dne. Why is it dne? Yeah, it's because the one-sided limits are not equal. That's why it's dne. It's because the limit as x goes to 0 from below is negative infinity, and that's not the same as the limit as x goes to 0 from above, which is positive infinity. That's how you would justify that. Please don't say, oh, it's 1 over 0, so that's not true as far as, now this is actually a point of contention, kind of teacher preference. Some college teachers or some high school teachers might want this done differently. What about this one? There's actually two possible answers. Make a case for yours. What's one? Does not exist. Make a case for your does not exist. Let me review the actual definition of the limit. A limit is the numerical value y approaches as x approaches what's given. So, tell me, why is there no limit? Yeah.
Because they both go.
Yeah, they approach infinity, and is infinity a numerical value? Not any more than democracy or love. Okay, infinity is not a number; it's an idea. Okay, so you could say dne because y does not approach a number. There's also another school of thought that says you should give a better answer. Okay, what's another answer? Infinity. Okay. Now, infinity is better because it bypasses the left-hand, right-hand degree. Do you agree the left-hand, right-hand degree here? Okay, because of the square, they are approaching the same thing. So it's not dne by virtue of that. So I would prefer infinity in my class, and you just need to be aware that sometimes, especially multiple choices, will only offer dne. Okay, they would never offer both. They would never say, "Oh, it's infinity or dne," and that would never be the case. Okay, but it is possibly the case that would say the limit doesn't exist, and they're just referring to this idea. It's not a numerical limit. You follow? Okay. Next idea of the day: continuity. This also might be, again, there's some people teach this in 3 steps and 2 steps. It might be a little different. Let me say this. If what Ms. Cannon taught you is different, go with it. It's fine. I trust her 100%. So if you're referring to your notes back from there, that's fine. I'm going to teach this the way kind of will lead you a little bit into adult epsilon, not to mention 3-dimensional limit problems. So I'm going to express it this way. Continuity, for continuity to happen, I'm going to say there has to be 3 things happen. The limit as x approaches c must exist. What does that imply? If the limit exists, then good circular reasoning. It's continuous if the limit exists. And if the limit exists, then it's, yeah, that's called circular reasoning. That's not good. Okay. No, what I'm looking at is that the one-sided limits are equal. That's what it takes for the limit to exist, is what I was looking for. You with me? All right. So the limit must exist. What else? So far, I've left open the possibility the left and the right hand have to agree, but what possibility is still there? There's a hole. So the second part is that f at c must exist. Okay, that's great, but I still have a possible problem going on in that, okay, f at c exists. Boom, there you go. Is that continuous? No, so the third thing is that the limits have to agree, the point has to be there, and they have to be equal. They must be equal. Wait a minute. Let's see. Okay, they must be equal. One second. Okay, now I expect you, when you get a continuity problem, I expect you to be showing work from the definition of continuity. Actually, I'll come to that in a second. Let's pause here. There are three typical types of discontinuity. What are they? Vocabulary. Jump discontinuity. Beautiful. Jump is when the one-sided limits are not equal. Okay? Other. Whole, the word for it? Whole's nice, but that's not the math word for it. It's called removable. Removable. Okay? Removable. If you were to describe analytically removable, it's that the limit is not equal to the point. Okay? What's the third? Asymptote, which we call infinite discontinuity. All right, get to know those sources of discontinuity. Study. All right, work required, especially with respect to piecewise. I avoid taking shortcuts. I like good work done. This is going to also lay the ground for integrals of piecewise. So I want to show you the work I want to see. The question for both of these examples, A and B, is f continuous at x equal 2 justified? What I best not see is something like this. Oh, 3 times 2 plus 2 equals 6 plus 2. Yep. That is garbage. Okay? And I will not take it. Furthermore, on the AP test, the first point for such a problem is shows limits. No limits. They wouldn't even look at your paper. They just put 0 on it and pass next. 0, 0, 0. Okay? If you don't show that you are working from the definition of the continuity, then you are not going to get full credit. All right? So this is what I should show. I need to show that the definition is satisfied. So I'm going to start, I wouldn't actually put probably 1 in there in my work because that's kind of arbitrary. But 1, do the limits exist? Well, what is the limit as x approaches 2 from the left of the function and the right of the function? Here's again where I'm a little picky. When you do a piecewise, you should start with the general and then go to the specific. If you're working with a piecewise, you should then identify which piece you're referring to at that point. If I approach 2 from below, which of the two pieces am I using? The upper, 3x plus 2. That needs to equal the limit as x approaches 2 from above. What's the upper function? 6 plus x. Now that your hand's worn out, now you can start doing the limits. What's the left-hand limit? 8. And the right-hand limit? 8. Okay. I have satisfied the first condition. Does the limit exist? Yes.
Yes.
The left hand, right hand are approaching the same thing. Okay. Second condition. Does f at 2 exist? Yes. What does it equal, by the way? It equals 8. Okay. In what case would a piecewise not have that condition met? Yeah, if there's no equal to it, if it just strictly said less than, greater than, f at c doesn't exist. It's not telling you what to do when x is 2. All right? And last but not least, we can say our conclusion based on the fact that those are equal. The limit is 8. Oops, I should have said the limit exists. The limit exists. It equals 8. Okay? Therefore, the limit exists and equals 8. The point equals 8. Everything's meeting, so f is continuous at x equal 2 because 1 and 2 are equal. The limit equals f at 2. Okay? That's super duper amazing, great work that I'd like to see. Try B on your own, please. Try B. Getting you started, do you need to do one-sided limits like we did the first problem, or you can just do stone cold limit? Stone cold limit. Steve? Did you get that the limit exists? Yes. Because that factor divided out, 0 over 0 divided out, what's going on graphically there? If you get 0 over 0, what does that mean about the graph? There's a hole. Okay, 0 over 0 indicates a hole in the graph. All right, so there's a hole at the graph, but the sides on both sides are approaching the same thing. What about f at 2? Does it exist? What does it equal? Okay. Now, this is what a lot of people call a fill the hole problem. You get a hole from the first part. They're giving you a piecewise to fill the hole. Believe it or not, this little pre-calculus idea kept students at our school anyway, about 7 years ago, just from doing anything on a series-free response problem. They couldn't even get started with other Calc 2 because they missed this one little pre-calc idea. It cost them, Anyway, that's why since then I've always made sure that you understand that this is just filling the hole. Cool? All right. Now, because those agree, you would say that the limit equals the point, and so f is continuous at 2. Wouldn't you say? Okay. All right. Did you do the sandwich theorem last year? I didn't talk to Ms. Cannon before class. I don't know if you've done the sandwich theorem. Have you ever seen the sandwich theorem?
Yeah.
No. Okay. Squeeze theorem. It's called squeeze theorem. Okay. It's kind of it's not a huge, gigantic idea of calculus. It is not, I've never seen it on the AP exam, or the AP exam, but I've definitely, professors always put it on their first test, so I don't want you to be at any disadvantage. I am going to, when I ask you one of these, I'm going to start you off by saying, use the sandwich theorem. Now, to me, that's really the hardest part is, if I just give you a naked limit, I sometimes have trouble getting started because obviously direct substitution doesn't work and sine of 1 over x does crazy stuff. So it's hard to get started if I don't lead you that way. And I just want to see that you can execute it, not that you can know when to use it. It's not that big a deal. All right? So in terms of how to use it, the idea is you don't know what this graphing is not really part of it. Don't use your calculator. You're not sure what this thing does as x gets closer and closer to 0. So you sandwich it in between two things you do know about. It starts by, start by using the range for sine. You have to find, actually, let's start here. Find what you can squeeze with. Now, by that, sine of 1 over x is probably pretty crazy. But regardless of 1 over x or not, I know that all sine has to always be between what? -1 and 1. Yeah? That's a fact. Now, equal to is important because it can equal. You agree? Okie dokie. Now, the second thing is you're going to then try and build towards what's given in the problem. This guy has this, obviously, but you need to bring in absolute value of x, yeah? Now, question, I have a three-part or trichotomy here, or three-part inequality. Can I multiply in by absolute value of x? Inequalities are are funky now. You have to, if you multiply by negative, what do you have to do? Flip the sign. But if you multiply by positive, do you flip the sign? No, so you have this, I don't know, should I flip the signs or not? But if you're multiplying by absolute value of x, do you really have that sweat, that issue? No, okay. So we're going to multiply by the absolute value of x, which is mathematically sound because it does not change the inequality. So that would mean I have negative absolute value of x is less than absolute value of x sine of 1 over x. Positive absolute value of x. Read? All right. Now the question is, this is kind of a notation thing. The question isn't what is the function everywhere. It's specifically the limit as x goes to 0. Now, if this function is less than this function is this less than this function, then as you approach 0, this should be less than this, should be less than that. And so I can bring in limits because that also would hold true. If they are less, then their approach should be less. So the limit as x goes to 0 of negative absolute value of x should be less than or equal to the limit as x goes to 0 of absolute value of x sine of 1 over x. Should be less than the limit as x goes to 0 of absolute value of x. Now, if you did this well, the outside limits should be nice. As x goes to 0, what is the negative of the absolute value of x approach? 0. Okay. And this is the question. I don't know what it is. But on the far right side, as x goes to 0, what is that about? 0. Now, the limit is between or equal to 0 and 0. So it must be 0. Graphically, what happened there is I'm sure this function did some crazy oscillation, but I know that the function was between positive absolute value of x and negative absolute value of x, which is just the flipped down version. I should have done that in some other color so it doesn't look like one function. And our function, I don't know what it's doing over here, but as you get closer and closer to 0, it's getting squeezed or sandwiched. Right? Okay. That's the idea behind the sandwich theorem. There's one of tonight's homework to practice it with, and if we need to, we'll practice it again. That's it. All right. Homework 3, if you get that out, let's see how you did. Strangers in the night, exchanging glances. Everybody. Homework from yesterday is on the back table. Take those 3 things, but you should have a book already, so not that book. Okay? If you were absent yesterday, take those 3 things on the back table. Okay. Did anybody look at my key last night? All right. I'm still trying to do this in a different way. So I forget to share. Get back to grade school with me. So I hope I am posting these right. I'm really just posting them for the benefit of 6th graders because they don't have books, so they don't have the answers in the back of the book. That's why I'm really posting the answers. But just so you know, in many cases, the answers to some of the problems or all of the problems I've been on my website the last few days. Okay, so going over at least the ones you didn't have answers to. Working down. Did you get 1, infinity, -1, negative infinity? Okay, the copies weren't great, so if there's the copy issue, oh, no, I guess the copies were okay. Second column, did you get something like 3, 1, dne, because the limit as x approaches 2 from the left of the function is something. What is that, 2? Is that a 2? Have I already done that? Oh, no. I haven't. Darn it. Yeah, I thought I had the evidence already in. It's a 3? So do I have the evidence in there somewhere?
Yeah, you did.
Okay, so I said that you had to cite evidence, but in if previously you've already done the one-side limits, you don't have to cite them again. If they're in your work already, you don't have to say them again. That's AP stuff too. Because the one-sided limits aren't equal, or because the limit as you approach, so that's a 2 or 3, did you say? 3, okay, is not equal to the limit as x approaches 3 from the left. Okay, f of -5 is 1. How'd those go? Super. F of g of x. What is f of x squared? Well, that's this guy, and so you get, actually, that's all I was saying. Did you simplify any more, or did you leave it there? I kind of had to leave it there. That's not -x, do you agree? You have to, it's kind of like painting a picture. You have to know when to stop and just let it go. It's done. Okay? X domain is x cannot be, or is, whichever you prefer. The only thing it can be is 0. So actually, there's only 1 point there. Nice job. Range. If x is 0, then the range is 0. I'm a little picky in that I know your geometry teachers are not so picky, but I'm a little picky. So there is no y in this problem, in my mind. What you really mean is the range is f of g. F of g is 0. But if you had a very strict professor, they would care. I just how about g of f, which would be g of absolute or square root of -x? That is -x squared. Is that -x? Is there any problem with that?
Yeah.
Give me a problem where this would work, but that wouldn't. This you're absolutely safe on. There's no doubt that's right. Question is that? Let's be careful. Do you agree that there's 100% no reason I can't do this? That is 100% true all the time. Yeah, I don't like it. Okay? What's the, I don't like this. What's the domain of this? Everything. What's the domain of this? You must put in negatives, okay? So this actually is the same as, let's just forget the negative for a second, okay? This and this, it's tempting to say yes, but no. If you were to graph this, your calculator knows this, by the way. If you were to graph this, what does the graph look like? No. Think. What does the graph look like?
Is it a straight or like a line in the first?
Okay, so with an endpoint, you're on the right track. So now I'm just looking for somebody to run it in with some vocabulary from geometry. Oh, thank you. It's a ray. Yeah, you're absolutely right. First quadrant line. Okay? Yeah, it's a ray, and this is a line. And so the answer is yeah, no. Not equal. They have different domains. Okay. So leave it. Fight the temptation to do that. and instead say the domain is s less than, what about equal to? Or 0. And the range, g of f, is greater than or equal to 0. We win. By the way, in my class and in the AP test, if they don't specify, you can use inequalities or interval notation. Either one. Okay. The backside. How did the old synthetic division go? Huh? Been a while. All right. What are the possible? Actually, a cube must have one root. Why? Must have a 0. Got it. Yeah, because of the nature of the graph. Doesn't it go like this? Surely it must pass through the axis. It's got to have one real root. How do I find the possible the rational roots? Factors of the first. So what are some things I could try to synthetically divide by? 1, 2, 3, 5, 6, 10, and so on. Anybody have any advice for what to try first? Did 1 work? You can just look at 1. Does 1 work when you put it in? No, 1 minus 19 plus 30 is not going to work. Let's try 2. And again, I'm synthetically dividing because they said 2. But if it didn't say, could I just try to put 2 in and see if it came out 0?
Yeah.
Yeah, I could do that. Okay, but it says synthetic. So I'm synthetically dividing. Don't forget the placeholder for the 0x squared. And if it is a root, then what should happen? What am I hoping happens?
It ends with 0.
Ends with 0. 0 remainder. So bring it down, multiply, record it here. Add, multiply, record it here. Add, multiply, record it here. And surely enough, 2 works. I'm throwing you a bone. If I were to further factor then, how could I factor it at this point? I know that x minus 2 is a factor, and what's left when I divide it out? Squared plus, oh, you're ahead of me. I guess that's true. Okay. So how does it further factor? X plus 5, x minus 3. All right. Now bringing the square root back, doesn't that mean then that I have a cube with 3 roots? I need to find, in order for square root to work, to find where it comes out positive, yeah? You could do, what do I do from here?
Sign test.
You could do a sign test. You could also use the graph. How would the graph of the cube, not the square root, but the cube help me?
You get the term.
Yeah, what's the shape of a cube graph? Yeah, what are the zeros? 2, negative 5, 3. Throwing the shape through that might be a quicker way than a sign test. So where do I say domain is good? Negative 5 and greater than 3 and 3 to infinity. Let's do interval notation. What about including negative 5 and 2? Do I include negative 5 and 2?
Yeah.
Because square rooting 0 is okay, yes? So negative 5 to 2 or 3 to infinity. Remember, if it equals, you use brackets. If it doesn't equal, you use parentheses. And you never use a bracket on an infinity, right? Okay. And then I have the graphs shown here. What does multiplying 2 out front do to the graph? Stretch vertically or horizontal? Vertical stretch. What does 2 inside do? Horizontal squish, mathematically speaking. I've actually never seen squish in a book before. All right, what about this? Reflect and up 1. Okay? Reflect across the x-axis, the y-axis. Plus we changed x's sign so it reflects the y-axis in that order. And what about how'd the inverse go? Did you get it? Okay. Somebody who feels like they got it, tell me a good way to go about this. How do you graph the inverse? Yeah. Yeah, just make a few points and switch the x and y. So for example, this point becomes 1, negative 3. So 1, negative 3, that's this point. Maybe this point is good. That point was 0, -2. So now it becomes -2, 0. This point was 2, 0. So it becomes 0, 2. And 4, -2 becomes -2. Okay, boom, you got your inverse. Inverse involves switching it to. Okay? All right. Any other questions on that homework you'd like to take? Oh, you're raising your hands. That's pretty good. Don't raise your hands, just say.
Could I get the 27 on the packet?
Oh, is that the limit definition one? Oh, wait a second. It just occurred to me, sorry. I will answer your question. Sorry, I didn't mean to bluff the question. But number, is there one that was the definition of the derivative, or the limit definition? Did you see a problem that said use delta epsilon and you didn't even know what the heck that they were talking about?
Yeah.
Oh, maybe I dumped it.
I had it.
I thought you had a problem that you did not know how to do.
27 in the textbook.
27, the textbook number 27. So, right next to the graph problem, 1.127. Yeah, you've never done a delta epsilon proof, so yeah, you probably shouldn't have known unless you read the book. Way to go, Richie. So yes, this one here, 1.127.
Oh.
That's actually not. It's not a bad effort. That's theoretical exercise. I got to replace it with something. So you can scratch that, or if you gave it a go, that's fine. I'm not going to look at it before I teach you. Apologize. When you said 27, that's what reminded me of. But you mean, is that what the one you meant, or 27?
No, I meant the one in the packet.
Okay, I got it. 27 on the packet. Actually, you get my stuff. No, it's right here. Let me get my packet here. 27. Oh yeah. Okay. Questions? Yeah, the old division is a little rusty, huh? I hear you, brother. I hear you. X plus 1 divided by x cubed plus 1. Can you use synthetic division in this case? This is an argument Mr. Bell and I have over one. Can you use synthetic division in this case? You cannot. Synthetic division is used for linear factors only. So you cannot divide by a cube with synthetic division. So he would argue, well, then you divide by x plus 1, and then the other two imaginary roots. That's ridiculous. Who wants to find all the roots of x cubed plus 1 so that you could synthetically divide by that? That's crazy. Okay? The long division case is far superior. Whether you put placeholders out there is up to you, but you probably want placeholders in. At least it helps me. You tracking?
Yeah.
All right. So how many times so just like when you divide numerically, I'm sure Mr. Baker will go on a rant about how people can't divide anymore, and he'll make you do long division in his econ class. But if I divide 52 I start at the left-hand side, 52 into this side, right? Same goes here. I look at the left-hand side. How many times does x squared go into x, or x cubed, excuse me, go into x to the 5th? X squared times. I put that here, and then I multiply. X to the 5th would go here. X squared would be over here. And then I change signs, draw the line, as Mrs. Lau used to always say. Oh, Mrs. Lau, I miss Mrs. Lau. All right, so these are gone. None of those, none of those, none of those. In fact, everything subtracts away, and you just bring down the next term, and that is a 1. That's not what I meant. That is a remainder. Okay, obviously it's a 1. The remainder is 1 over x cubed plus 1. That's your answer. How could I verify if my life depended on it? That is right.
Multiply times x.
I can multiply it by x cubed plus 1. Okay? Okay, does that ring a bell? Yes.
Couldn't you also write it as a fraction of x to the 5th plus x squared plus 1 over x to the 3rd plus 1, and then you could factor out an x squared from the x to the 5th plus x to the 2nd, and then you could split them apart, and then you could...
Did that get you?
Yeah, I got that.
Oh, that's a good idea. I like it. Yeah, definitely. Okay, other questions? Okay, I'll just be walking around. Make sure I get this by the end of the day. in the basket at the appropriate time, and you have the homework. Yes, you picked it up. We're good. Okay.
You know why?